We'll just start from scratch here. All right, so question was, how do we use these coordinate pairs? We talked about how we could use like degrees, radians are just another way of writing degrees. And what do we use these coordinate pairs for? Anybody remember like how we could, what are these good for? Yeah?
X cosine and y sine.
Good, yeah. So we said that x was the cosine of the angle, y is the sine of the angle. So if, for instance, I asked you to find, let's say, the cosine of 2 pi over 3, well, then you would go to 2 pi over 3, and you look for the x coordinate. So you could say, oh, that's negative a half. If I ask you what is the sine 210 degrees, well, you can go to 210, and y value, it's also negative a half. So now, in addition to this sine and the cosine, we actually have a total of 6 trig ratios. These are the two most common ones that we use often, most often, sine and cosine, because, well, they're the ones that are represented by the circle. But actually, all of them we can represent with the unit circle. So there's 6 total. You're probably familiar with at least the first 3, maybe not in the next 3. Well, let's go ahead and write them all out here. So all of the trigonometric ratios. We're going to talk about these a lot. So much you'll probably get tired of trig ratios after a while. But most of the rest of the year we'll deal with these in some way. All right, so our first one we're going to say is the sine of theta. This little symbol just means the angle. Little Pokeball symbol. So the Greek letter theta. Somebody did Pokemon. Or not brave enough to admit it, maybe.
Yeah.
All right, there you go. Nice. Nothing wrong with Pokemon. Wasn't it Pokemon Go? Did anybody ever do that? Yeah. Was that pretty fun?
It was.
Yeah.
Yeah, so it's like pull it up and
I never played it, but it looks pretty fun.
it's a different game. That's
All right, so the sine is the y, the cosine is the x. The cosine is the angle of the x. So with those. All right, now the third one you've probably heard of before is the tangent. Okay. We just abbreviate it tan. And anybody remember the relationship between sine and cosine and tangent? Tangent is like something over something. Remember that? I'm sure you've seen before, tan is the sine over the cosine. You've seen that before. So if that's true, if tan is the sine over the cosine, that means it's going to be the y over the x. So we can find the tangent of an angle by taking the y coordinate over the x coordinate. All right, so these are the 3 main ones. Now there's actually 3 other ones. They're less common, but you do need to know them. The first one is called cosecant. Cosecant. I don't know where I got here. Cosecant. Cosecant. Abbreviated CSC. The cosecant is the reciprocal of sine. These two are reciprocals. Reciprocal means that you flip the fraction. So the cosecant is going to be 1 over y. So you can find that out by looking at the unit circle as well. So those two are a pair, sine and cosecant. Cosine also has a match. His name is secant. SEC stands for secant. So the secant of theta is 1 over x. So these also are reciprocals. And tangent also gets a match as well. And this tangent match is called cotangent. COT stands for cotangent. And you can see these are also reciprocals, and this is y over x. Cotangent is x over y. So you will, when we eventually have like a quiz or test over this, you'll actually need to know these. You'll have to have these memorized. I think we'll use them enough that will just get stuck in your head. But you will need to know those. So a couple observations. Tangent and cotangent, those are an easy match, right? Tangent, cotangent, they pretty much almost the same thing. These not so much, because you probably would think sine and secant should go together, right? Sounds right. Sine and secant, cosine and cosecant. That's not the case, though. What you have to remember is these are the opposite. I just remember they're the opposite of what you think. You would think sine and secant because it would start with an S, but it's not true of the opposite. You would think cosine and cosecant because they're the opposite. You just got to remember the S goes with the C and the C goes with the S. I don't know a good way to memorize that other than I just tell myself it's the opposite. What do you think? All right, so let's use these. We're going to do this on a Desmos. You're going to want, you can have your unit circle out. It'll probably be helpful to have it for this. And also like something to write with, along with your computer there. So computer, log into here, and something to write with, and your unit circle is probably going to be helpful as well. See what we've got here. Sorry, I need to get restricted here. All right, so what we're going to do is use our knowledge of the unit circle. And you can have it out though, even if you haven't memorized, it can still be helpful here. So we're not going to use a calculator. We're going to write all of our answers as a fraction, not a decimal. And we're also, this is going to be the more challenging part, rationalize all denominators. Rationalize means to get rid of any square roots in denominators. Yeah. Code GB8 DBB. GB8 DBB. So the correct way to write anything in math is without a square root in the denominator. So no square roots in the bottom of fractions. Right? So keep that in mind. Here you go. Decide how you're doing. It's kind of fun to just play around with this. The guy's face changes and his color changes. I don't know how you're feeling. Very good. A couple people not doing so well. I'm sure this will cheer you up doing that. All right. Your first assignment here is to just match these up. So we just did this. Hopefully you wrote it down. Match the pairs. Which ones are reciprocal to each other? And I'm going to show your correctness up here. So you can find your name up here. You'll have to look in the top left of your screen to figure out what your mathematician's name is there. And you can see if you did it right. Very good. All right, next one. This is how we're actually going to use the unit circle. So we'll start off very basic. You need to find the sine of 0 degrees. The sine of 0 degrees. So what you're going to do is look at your unit circle. Go to 0 degrees here. And the sine is the y coordinate. So the y coordinate at 0 degrees is 0. Easy enough. I'm just going to type in 0. Submit. Should be 0. All right. Easy warm-up question. Get a little bit harder here. What is the sine of pi over 3? Sine of pi over 3. Now, you might be able to do this without a unit circle. You can try it. You could always verify. I'll kind of walk you through how I do this without a unit circle. If you do end up taking calculus ever, then you would just have to know what the sine of pi over 3 is. So kind of the process is you go think where pi over 3 is on the unit circle. It's up here, right? This pi over 6 is here. Pi over 3 is up there. And the sine is the y coordinate. So you think, well, what's the y coordinate? Well, it's radical 3 over 2. That's what we're going to type in. Radical 3 over 2. All right, still pretty easy so far. Cosine of 5 pi over 4. Cosine of 5 pi over 4. So you need to think cosine for the x and y. That's the x coordinate. Any of the x coordinates with a 4 on the bottom, those are always the quarter marks, right? So it's always going to be a radical 2 over 2. You just got to think about what quadrant it's in. 5 pi over 4 is there in the third quadrant down here. So it's negative. So just make sure you get the negative sign with it. Negative radical 2 over 2. All right. Cosine of 300, the last easy one, and then we'll get a little harder here. Cosine of 300. So that's the x coordinate at 300 degrees. So the x coordinate at 300 should be 1/2, positive half. All right, let's get a little crazy here. The tangent of 150 degrees. So take a second to see if you could figure that out. The tangent of 150. Chances are you'll probably get a little confused on this. Let's see what you can come up with though. So hopefully you're able to find 150. The tangent is y over the x. So we need to put 1/2 over negative radical 3 over 2. All right, so 1/2 over negative radical 3 over 2. Can we just type it in like that? Does that work? Yeah? The phone doesn't tell you it's right, does it?
Yes.
It does? Well,
Yeah.
shouldn't. That's not right. Shouldn't. Okay. Well, it's not right. Well, it's not the right way to write it. So this is not a good way to write an answer. A fraction and a
Oh,
fraction.
it's right for both.
Right, yeah. So well, yeah, I guess you could say it's right. It's not simplified. You would never actually write an answer like this as your final answer. So how do we simplify this? No, square it, no. How do you simplify? Okay, let's say if this was instead, if it was just half over 3/2. Okay, forget the square root part. What would you do? Yeah. Yeah, but the denominator flipped, right?
Yeah.
So do you guys remember like hearing like keep, change, flip maybe? Or keep it, switch it, flip it? Remember that? When you divide fractions, keep, change, flip. So what that means, when you divide fractions, is same as multiplying by the reciprocal. So this is 1/2 times, we flip this one and multiply. So negative radical 3 over 2. Oh, sorry, I didn't flip it. Oops. Negative 2 over radical. No, it's not even letting me write. Alright, negative 2 over radical 3. Alright. So we keep the top, we change it to multiplication, and then we flip the bottom. Keep, change, flip. So we kept the first fraction exactly the same. We changed this from division, this is division, to multiplication, and then we flip the bottom. Okay? Keep, change, flip. So then what happens? Notice this cancels with this 2 because they're diagonal to each other. Now we have negative 1 over radical 3. That's still not a good answer because at the beginning, we said here, we have to rationalize all denominators. No square roots in the bottom of the fractions. So by its own definition, that shouldn't have worked when you typed it in. I don't know why I said that way, but. So now the question is, this isn't right yet, but how do we get rid of that square root in the bottom of the fraction? So when you rationalize, yeah. You can't just square it because it would change the value of this. It's not really like set equal to anything. It's not like x equals. But you got the right idea. You can't. Unfortunately, you can't do that because that would change the value of what it is. Any other ideas? So here's what you do. This is called rationalizing. You're going to multiply this by the square root of 3 over the square root of 3. So why am I allowed to do that? Yeah, square root of 3 over square root of 3. This is just 1. Right? That's equal to 1. You can multiply anything times 1 because it doesn't change its value. Right? And 5 times 1 is still 5. So I'm multiplying this by itself because the same thing as multiplying by 1. So it won't change the value. But what it does do is when you multiply a square root of 3 times the square root of 3, the square roots cancel. It just gives you 3 on the bottom. On the top, I've still got negative 1 times square root of 3. So it's negative square root of 3 over 3. That's your answer. Negative the square root of 3 over 3. We're going to do a lot more to practice that, a lot more like that. But that's our process. So we're going to keep, change, flip, keep the top, change it to multiplication, flip it. And then if we have a square root in the bottom, we have to multiply by the square root over itself. So negative radical 3 over 3. Correct answer. All right, let's go ahead and try the next one. Tangent of 7 pi over 4. Tangent of 7 pi over 4. So it's going to be your y over your x. And you want to go to 7 pi over 4. Now, any of the ones that end in pi over 4s are going to be the radical 2 over 2s. And anytime you have a tangent, it's actually going to be really the same thing over itself. You'll end up with a radical 2 over 2 over radical 2 over 2. The only thing is you got to make sure you get the right sign. 7 pi over 4, that's in the fourth quadrant down here, right? Where the y is negative. So what you would have is negative radical 2 over 2 over radical 2 over 2. What does that equal? Yeah, this is just negative 1. Because the top and the bottom are exactly the same. This is the same as this. So they actually just cancel. Leaves you with just negative 1. So you don't have to go through all the extra work. If you still did it, you'd see it would work. If I did the keep, change, flip, keep the first, change it to multiplication, flip it, and look like this, and you would see that they're still going to cancel. So square root of 2's cancel, 2's cancel, really it's just negative 1. All right, let's keep going here. Best way to do this is just to practice. Got a scenario here that first, Stu says that when you have to find the cosecant, secant, or cotangent of a function, you just make the opposite of the number. Kim says no, turn it upside down. Explain why Stu and Kim are not using good mathematical language. How would you explain to a friend how you find the cotangent, secant, cosecant using good mathematical language? So what's wrong about what they said? Stu says just make it the opposite. Kim says turn it upside down. Why is it not good? Or is it good?
Good.
All right, good. A lot of good answers. This one's really good here. Lynn Conway says, term they should be using is reciprocal. That's correct. Should be using reciprocal. It says, Stu says to make it the opposite. The opposite of a number is actually what it means to change the sign. So like if you had 2, the opposite would be negative 2. And then turning it upside down, yeah, this is actually kind of a fun thing to do. When you say turn it upside down, try to write a number upside down. Try to write 2 upside down. It's kind of fun. You actually flip it and try to do that. But it's even more fun if you try something like radical 3 over 2. You try to write that upside down. You should try it on your own. You guys should try it. So you gotta do the 2. Actually, sorry, you gotta start with the square root of 3. So you gotta go like, and then you gotta do the 3, and then you gotta do your 2. That.
I write all my.
So if you said turn it upside down, then well you might have to write your answer like that. Yeah. Reciprocal is the right word. Oh, that's actually pretty good. I had one chance to practice though. All right, let's try the next one. The cosecant of 210. First thing you want to think is cosecant, that is 1 over what?
Yeah.
All right, 1 over y. Find that first, and then you go to 210, find the y coordinates, and then you do 1 over that y coordinate. And then you might have to simplify it. So the y there at 210 is negative a half. So you're going to have to keep change flip with that one. Keep change flip and simplify. See what we got here. I think we have a variety of answers. So we don't want to leave a fraction in a fraction. Don't get in the habit of doing that. Oh, another thing. Sorry, I don't want to pick on anybody, but this is like you can never have a decimal inside of a fraction. Okay, especially. So you don't want a fraction in a fraction. Definitely not a decimal in the fraction. So those are like two different ways of writing it. So don't ever write a decimal in a fraction. All right. What you would want to do is keep change flip. So keep the top, change it to multiplication. You flip the bottom to negative 2 over 1. So then you multiply straight across. 1 times negative 2 is negative 2. So obviously, negative 2 as an answer is better than like 1 over negative a half, right? Or 1 over negative 0.5. Because you might not even know what these mean. But if you have negative 2, it's much easier. Try the next one here. These just take a lot of practice. We're going to practice more tomorrow as well. Let's try the secant of pi over 6. Secant, so think about, well, secant matches with cosine. Cosine is the x, so it's got to be 1 over x. One over the x at pi over 6. And you might be able to get pi over 6 without looking at your unit circle. This is just the first one. The easy part is getting the 1 over radical 3 over 2. The harder part is simplifying that. You keep change flip. So 1 times 2 over radical 3. That's just 2 over radical 3. We then have to rationalize this. We can't leave that in the bottom. So we're going to multiply by radical 3 over radical 3. We know the bottom may cancel, so it leaves us with just 3. The top, it might look kind of weird, 2 radical 3, but that's actually the answer. 2 radical 3 over 3. That's how you're going to want to type it in. 2 radical 3 over 3. I know it seems complicated, but it's the simplest way to write the answer. Got a couple more here to try. All right, cotangent of 4 pi over 3. Cotangent is the x over the y at 4 pi over 3. There you did. 4 pi over 3, right here. The cotangent is the x over the y. So negative a half over negative radical 3 over 2. That looks kind of nasty there. So then we take the top, negative a half, multiply, flip the bottom. Did we go past that? You change flip. Did you get this part right, Alyssa?
No, I just never knew how to keep track.
Oh, okay. Wait, now you know. Keep the top, change the multiplications, flip it. Twos cancel, they're opposites. The negative signs cancel. So we have 1 over radical 3. Then we do our same thing we've been doing. Multiply by radical 3 over radical 3. So we get radical 3 on top, 3 on the bottom. After you do it a few times, it's not too bad. We got time for one more here. Let me see. Yeah, this will be our last one. Try this one on your own. Give you a minute or two here. Try that out and then go with the answer. Secant of 135 degrees. So secant is going to be 1 over the x. 135 is going to be negative radical 2 over 2. So we keep change flip. 1 over 2 times negative 2 over radical 2. This becomes negative 2 over radical 2. This one you multiply by radical 2 over radical 2. That gives you negative 2 radical 2 over 2. And then the 2's actually cancel. So this is negative radical 2. So we'll practice this some more tomorrow. Tonight, I'm not going to give you homework over this because you have the unit circle quiz. So study that if you need to study that for tomorrow.